Hi, welcome to Engineering 160A, Studio Session 1.2b, While Loop and Waveform Chart. The tutorial objective is to generate a simple program to demonstrate the use of a while loop and a waveform chart. The program is to continually calculate and display a sine wave. In order to do this, we'll have to utilize a while loop. Also, we're going to learn and use what is a waveform chart. This is a visual display which acts similar to a laboratory strip chart and produces a real-time plot as each new data point is generated. Let us begin by starting a new blank VI. Well, what we want is to generate a sine curve, and in order to do that we want to utilize the structure known as the while loop. In my block diagram, let's go ahead and right-click to bring up my functions palette. Okay. If I wanted to leave my functions palette up, I can always put this pin down here, and then you can see it will change and the window will always be on top of the screen. Okay, I can close that out if I want to. Okay, so we're in the functions palette. We navigate down to structures and then we can find our while loop. So we left click and now we can place this in our block diagram by left click and hold, drag to size the while loop itself, and then release. And that will bring up my while loop, which again has an iteration block and my loop condition. The loop condition needs a Boolean value, a true or false, and the way it is set up is it will stop if a true is sent to the stop sign. If a false is present, then the task which is within the while loop will continually occur. If we didn't want this to be the case, for some reason we may want the while loop to stop when I send a false, I can set that by just hovering over the loop condition, right clicking, and then going down to continue if true. Okay? And now it is set up such that a false will stop the while loop. But the standard and more commonly used is stop if true. If I want to resize my while loop, all I need to do is hover over the corners and grab one of these blue squares, and you can see I can resize my while loop accordingly. If you don't have this functionality, then it may be an issue with your tools palette. One thing to check is you can go to View, Tools Palette, and that will bring up a window of the tools palette where there are many different options which control your cursor. So here we have operate value, position, size, select. You can make your cursor place text somewhere, scroll through the window, shortcut menu, connect wire. Okay, the way I like to work with LabVIEW is to just leave it on the top here, which is automatic tool selection. That will allow LabVIEW to smartly select what cursor you have based on your position on the screen. So what do I mean by that? You'll notice now that I'm selected as an automatic tool, I have some cursor, and then depending on where I am, like if I go over a terminal here, it realizes that I want to connect wires, it automatically changes itself to the wire connection. And if I go to one of these blue squares, it automatically changes to a size selection tool. Let's go ahead and try and calculate my sine wave. I need to somehow calculate the sine function. And as you may guess, LabVIEW has a lot of these common functions already built in. So let's right click, bring up our functions palette, and we can go down to mathematics, and then under mathematics there is a elementary subsection, and then even further we have trigonometric functions, and one of those trigonometric functions is indeed calculating a sine wave. So left click, drop it down inside my while loop, and now let's figure out how to use the sine wave. Well, in order to do that, we can always at any point hit Control H, and Control H will bring up a context help menu and will help us understand how to use different objects. So once our context help menu is up, whatever I select, whether it's the while loop or in this case what I want to look at, the sine function, it will highlight to me what are the inputs and what are the outputs to this function block. So here it says it computes the sine of x where x is in radians. Okay, so whatever comes in to my input side, I'm going to get out the sine of that value. Okay. So if I want to continually develop a sine curve, I just want to keep increasing the number that I put in for x, starting from 0 and then continuously increasing with time. Well, one easy way in which I can do that is by utilizing the iteration number of the while loop. Recall that the iteration number starts at 0, then the task of creating the sine wave will occur. Once that's completed, if a true statement is not sent to the loop condition, the process would begin again and my iteration number would increase to 1. So every time I'm looping around, this value that's stored in this iteration number will go from 0, then 1, then 2, then 3, so on and so forth. Let's say I wanted this program to continue on forever. If that were the case, then I would never want a true signal to be sent to the stop condition. So one way I can do that is I can hover over the terminal, right click, and then I can easily go to create a constant. And now I get a Boolean sort of constant, and it's set here as f for false. I can easily change by left clicking on it and become true, but if I leave it as false, that's going to continually run this while loop, right? Because every time it completes the task of calculating the sine wave, the false will be sent to stop, and it will go and continue again and again and again until I manually stop the program by hitting the abort execution button up top. In order for the user to be able to visualize the sine wave, we're going to have a display, and that can always be found while working on my front panel. So let's go ahead and switch over to my front panel, and when I right click on the front panel, I get a completely different menu. This is the controls palette. And we can go down under modern to graph, and there are many different graphs: waveform chart, waveform graph, XY graph, so on and so forth, and we will learn more about the different functionality of each of these. But for now, we're going to be learning about the waveform chart. So let me select that and place it down on my front panel. Once I place it down, you see my text is highlighted, and therefore it is editable. I want to leave it for now as being called waveform chart. So to accept this, I can go ahead and just click this check mark above here. Okay. Now that we have our waveform chart, if we wanted to resize it, we can always click on it, and then again we can resize it any way we want. And more importantly, what we may want to do is rescale the y-axis. For us, our sine wave is going to be going from a value anywhere between -1 to +1. So what we can do is we can double click on the 10 there and just change that to the value of 1 and then hit enter. And then we can double click on the bottom of the y-axis there at -10 and just change that to a -1 and then hit enter. If I wanted this to be saved every time the program was closed and then reopened, I should go to edit and then make current values default. The waveform chart has a lot of customizable options which can be accessed by just right clicking on the waveform chart itself. And here we can do a couple of things. We can go to visible items, we can turn on or off that label. Let's leave it on for now. Another thing we can do is instead of changing our scale manually like we did from going from 1 to -1, we could go down to Y scale and notice that we have a auto scale Y option, which is checked by default, meaning that it will auto scale once data starts to come in. One of the customizable options that we want to look at now is something called the scale legend. So let's right click, go to visible items, and let's go to scale legend. And you'll see is this will automatically pop up this window down here where we can go in and manually change the name of the x-axis, or we can change the title of the y-axis. In addition, there's a couple of features here. This lock here, this is the auto scaling. If it is on locked where it's actually closed, then auto scaling is automatically on, meaning the user could not change the axes as the program is running. If it is open, then auto scale is off. If you want to auto scale just the x or y axis once, then you can click the next button here. Lastly, we have the formatting of the numbers that occur on the scale. So we can change from decimal to scientific, and you see the axes themselves change their formatting. Let's go ahead and edit the name of our x-axis by highlighting time and changing it to what it will be for our program, which is just the value of x in radians. So let's write x and radians. Let's also change the y-axis. Instead of just saying amplitude, let's say this is the sine of x. Okay. Click away, and you see my y-axis changes to sine x. There's one last step that we need to complete before we are able to run this program, and that is to jump back to my block diagram. And once I've done that, we see that because I placed a waveform chart down on my front panel, there is a corresponding icon in my block diagram which still has nothing wired into it. So we see there's some input to that waveform chart, and this will be the data that comes in to be plotted. So we want the sine value to be plotted, so let's just take the output from that sine function and connect it up to my waveform chart. Okay, let me run the program, and before I do that, I'm going to make sure I have my y-axis in the locked or auto scale on, and I'll have my x-axis with the auto scale off. So let me go up and hit the run button, and ooh, it looks like we have a sine wave, but it is traveling very, very, very fast. The reason for this is a new data point is being plotted on the screen at a rate which is as fast as my computer can do the calculation, and it's something most likely on the order of about 0.7 microseconds. In order for me to stop the program, my while loop is continuously going to run because the condition loop has a false constant set up to it, so the only way for us to stop it is to go ahead and hit the abort button. This in general is not a good way to stop programs. It has a hard halt on your computer's operating system, and it is always better to actually somehow have a off button placed inside my program itself. So let's go ahead and try and do that. Let's go back to my block diagram, and now instead of having a false constant, let me somehow have a button placed such that a user can stop the while loop from occurring from the front panel and not having to abort the entire program. Hover over the terminal of my loop condition, right click, and I can do create a control. It automatically comes in as a stop button, so I can double click on that, and that will automatically bring me to where that stop button was placed on my front panel. So I can move this down, maybe I'll move it under the graph here, and I can resize that stop button. Now when I run the program again, I have my data coming in at this extremely fast rate, but now for me to stop the program, I can now hit this stop button, which sends a true value to my while loop condition statement telling the while loop to stop.